really that was useful. But anyhow, we'll start. But actually, I wanted to do. Basically, as I told you that when we talk about semiconductor devices, there are many electronic basic components which are called active components, apart from resistor, capacitor, and inductor, which is called passive components. Active component, already I told you, diodes. Then what you have, transistors. Third one is FET, which is called a field effect transistor. Then you have advanced version of a better version of called MOSFET. Correct? MOSFET we are going to see later. FET and this one we'll see it. Then you have the thyristor family. What you call as SCR, which is called as silicon controlled rectifier. SCR. Then the next one is called as a diac. The third one is called triac. These three, the thyristor family, are generally used for controlling and rectifying AC motors and AC power supply. AC motors and AC power supplies. Power supply. Rectification, we'll see that what it is. We'll see that anyhow, mainly we are going to see our SCR and advanced version diac and triac. Similarly, MOSFET. Now, I told you the power electronics is there are all these devices, two categories. One is called small signal, other one is called power electronics. What it differentiates, small signal means the bias voltage will be generally will be less voltage. What is less voltage? Different books talk differently. 0 to 30 volts, 0 to 40 volts, or 0 to 24 volts. Correct? So some books are 30, generally not very high. If the supply voltage VCC bias voltage is less than 50 volts, you can take it. They are called as small signal amplifier. Many times it can be 10 to 24 also, some books. Power amplifier means the voltage applied can be hundreds of volts. Hundreds of volts. Sometimes even thousands. Thousands of volts. What did it mean? I can say that 100, correct? 2000 volts. Or it can be 100 to even 5000 volts. Correct? So this is what we call a high voltage. They call very high voltage, correct? It's called a VHV. Some books call it very high voltage. So this diodes, transistors, or MOSFET, thyristor can, if it can handle or supplied with greater than 100 volts or greater than 50 volts. I don't know, give greater than 50 volts, correct? And go up to 500 volts, 600 volts, 800, 1000, 2000, up to 5000 volts also. Special transistors are there, correct? And also, they're called as power electronic devices. Power electronic devices. Not only they can high voltage, they will handle high current also. Generally, small signal amplifiers, when I say small signal amplifier, current may be in the order of milliamps. Correct? 10 maximum current. We are talking about ICC max or IC max. Correct? It will be in the order of milliamps, less than 1 amps. Generally. Correct? They are called as small signal amplifiers. In power amplifiers, current can go to tens of amplifier or hundreds of amplifier. 20 amps, 30 amps, 50 amps, 200 amps, 500 amps. Okay? So then high current and high power. They can handle high power. Power is V into I. We are talking voltage there, for example, 1000 volts into, say, for example, 100 amps current. You can see that so much power, correct? So sometimes the big power transistors are there. Sometimes it's the same power can be handled by 2 or 3 power transistor connected in parallel manner. We can see that. Okay. So these are called power electron devices used for driving your electric motors used in hybrid and electric vehicle. Okay. Now we wanted to talk about what is called as half-wave rectifier. So what is the job of rectifier? Rectifier is a device which converts AC voltage into DC voltage. Simple definition, correct? AC voltage into DC voltage. That is called as rectifier. Any device, correct? Any device which converts a AC voltage into a DC voltage is called a rectifier. So, yeah, very popular. This one is a diode, correct? Diode is main purpose. Diode is that it can be used as rectifier to convert the AC voltage to DC voltage. Other devices which can be used are SCR and TRIAC. These two devices, including DIAC also. SCR, TRIAC, DIAC, which is called thyristors. These devices also can be used as rectifiers. These four devices are used as this one. Now, let us start with widely used the rectifier. Again, rectifiers are divided into two categories. One is called half-wave rectifier. Note down. Half-wave rectifier. Other one is called as full-wave rectifier. There are two categories, half-wave and full-wave category. Now, let us start about half-wave rectifier. Okay. So, when we talk about half-wave rectifier, so what is job? It converts AC voltage to DC voltage. From where it gets AC voltage, generally it will be receiving from the grid, correct? Grid power, what we call as AC voltage generated power station. That voltage comes in high tension coil in thousands of volts, which is converted to 220 volts or 400 volts in India. Correct? Single phase voltage means it is 220 volts, three phase voltage, 440 volts between phase to phase. That is what is supplied to any appliances, which can be motors, three-phase motors, single-phase bulb, TV, fridge, all those things which operates on AC voltage will receive 220 volts or 440 volts in India. Correct? If you go to US, it is 110 volts. It is 110 volts. Phase to phase, it will be 220 volts. Okay, instead of 440, that is what in US. So we will talk about half-wave rectifier, how it works under circuit diagram. So generally, the input power coming from the grid is 220 volts. Sometimes I want, for example, 24 volt DC voltage for driving some electronic circuit. That's what you want. Electronic circuit, you know that bias voltage means you have to supply DC voltage. Please note that again, somebody in interview asked, you cannot supply AC voltage as a bias voltage for any electronic circuit. Transistor amplifier, FET amplifier, or memory IC, or CPU, correct? Use embedded controller, your i7, all these things. Most 99% of electronic circuit which is working requires a DC voltage as a bias voltage. Already we saw VCC and VBB for transistor. In case IC, we supply voltage, ground voltage. So, but basically we are getting the AC voltage only in the grid. Then you need a rectifier to convert the AC voltage into DC. AC voltage to DC conversion is done by a rectifier circuit. Correct? Rectifier circuit which will provide DC voltage. AC is input, output is DC. Okay, what is the half-wave rectifier? So, if I want to 24 volt DC, but we know that what I'm getting is 220 volts. Then, first thing is the AC voltage 220 voltage should be stepped down to 24 volt AC voltage. For that, we'll use transformer. We will use transformer. This is symbol for transformer, all of you know. Correct? So, this is called primary coil, P coil. This is called a secondary coil, S coil. And this will be supplied with AC voltage 220 volts. 220 volts, 50 years. I am supplying to primary coil. And primary coil number of turns I call is N1. This is called N2. This is called secondary coil. Here you are getting. If you give 220 volts, and already we know that if transformer ratio is 10, I say that transformer ratio. What is transformer ratio? Already we know. I know that N1 is the number of turns in the primary coil. N2 is the number of turns of secondary coil. Transformer ratio equal to N2 divided by N1. Okay. So that is going to be this one. Now, if already previous also mechatronics I already told you, there are two type of transformer. One is called step-up transformer. Other one is called step-down transformer. Okay. If this is a step-up transformer, what will be that? N2 will be greater than N1. Okay. What is N2 is number of turns, coil turns of secondary. N1 is number of coil turns of primary. Correct? So the transformer ratio generally defined as number of turns of secondary divided by number of turns primary. Okay. If it is a step down transformer, correct, it will be N2 will be smaller than N1. So this is called a step up transformer. This is called as step down transformer. Why it is? Now we can calculate transformer ratio. Now see the formula. The V1, I can say VP, correct? VP is called primary voltage. VS is secondary voltage. VP, correct, multiplied by TF equal to VS. Okay. So we know that TF equal transformer ratio, TR. Transformer ratio TR equal to VS divided by VP, which is nothing but N2 divided by N1. You can write transfer ratio as out number of secondary turns divided by primary turn is called a transfer TR. Okay. Now, if TR is less than 1, it is step down transformer. Okay. If TR is greater than 1, then it is called as step up transformer. That means if for example, N2 equal to 200 turns and N1 equal to 100 turns, what is my TR? TR equal to 200 divided by 100 is TR equal to 2. Okay. If TR number is greater than 1, it is step up transformer. That means if I give 220 volts and say in the secondary coil, you will get 440 volts. It will be 2 times it is multiplied, correct? 100 divided by 200 equal to 2. My transform ratio, I can say that the secondary voltage, which is the output, is nothing but TR multiplied by VP. Correct? TR is 2. Okay. VP equal to, I said 100. So then VS will be 200 volts. So then this transformer is step-up transformer. Similarly, if we talk about the transformer, N2 equal to 50, N1 equal to 100, TR, transformer ratio equal to 50 divided by 100 because it is N2 divided by N1. So we can say that this is going to be 0.5. TR is going to be 0.5. Now, if my VP equal to 200 volts, VS will be 200 multiplied by 0.5. It gives 100 volts. Right? So this transformer is called step-down transformer. Okay, because step-down if I want lesser DC voltage from rectifier to supply electronic circuit, the grid voltage should be reduced to the level what I want DC voltage. Okay. So now rectifier using junction diode. Generally, it is called junction diode. Correct? It is called a junction diode. Simply we call diode. Diode is semiconductor, which is called PN junction. P-type is this one. So the circuit diagram for a simple half-wave rectifier, diode rectifier, I can say that is a transformer supplied with an AC input, well, I say 220 volt, 50 hertz, single phase. This is a transformer 4, and if I put a diode like this, then connect it to a load RL. This is nothing but load resistor. This is my diode. You can see that anode is this is cathode. And this is my secondary, which is now VS. This I called as VP. I am applying VP equal to 220 volts, correct? And for example, this is N2, secondary number of turns, this is N1, and I say the N2 equal to 50, and N1 primary coil equal to 200. Okay, what is my TR? TR is nothing but 50 divided by 200 is going to be 0.25. Okay, so that means I gave 220 volts. It should be multiplied by VS when VP equal to 220 volts. For in this one, VS will be 220 multiplied by 0.25. Okay, so it is going to be 55 volts. VS is going to. So what is this voltage? What we are applying this? So I draw graphically, note down. The input voltage is a sinusoidal in nature. This is VP. Axis, this is the VP. Here it is 0. This side it is positive. This side it is negative. So it is varying sinusoidally. Correct? Already you know that. Now, if I give this voltage to the primary, and what is the voltage giving? Here 220 volts we are giving. Please note that whenever you say 220 volts in India, single phase, okay, and 50 hertz, what it means is it is called VRMS voltage. This voltage is called as voltage root mean square value. Correct? VRMS means voltage root mean square. They are called is 220 volts. Now, in this is called as 0 volts. It is increasing. This point is called as positive V peak. Correct? This is called as minus V peak. Generally, nobody read fully. Instead of that, they say plus VP and minus VP. That is nothing but what is the maximum voltage of the negative sine wave, and this is positive side. Now, there is a relationship between VP equal to root 2 times VRMS, note down. Okay? Whenever in India, if somebody says 220 volts, it is nothing but VRMS voltage. Okay? This value is called peak value, correct? So how will you find a peak value? Peak value can be found using this value, correct? You know that in this case, root 2 is 1.414 approximation multiplied by 220, correct? From that, you can find VP value, whether positive or negative. So this is my input. When I give, this is given, what is this voltage? Primary side, the peak voltage is going to be 220 multiplied by 1.414. I think it will come something around 400 something. 220 multiplied by
311.
311, correct? So it will come 311. So my V peak will be 311 volts. Please notice still it is varying sinusoidally. Every time after each cycle it crosses 0 twice. So this voltage given as the primary. And my secondary coil 50 turns. So what will be the VS only? VS will be 200 multiplied by 0.25, correct? Is going to be 50 volts. How it will be? This is my VP. Vs also will be same as that Vp. Only thing is amplitude is reduced by 4 times. Okay. So you can see that it will become smaller voltage. Okay. What is this positive feedback? It will be 50 volts. Negative volts minus 50 volts. Okay. This is the Vs voltage. This Vs voltage is applied to diode. Correct? This Vs voltage is applied to diode. Okay. What will be my output voltage? In that case, I can show that in next slide. All right. Let me show here itself. This voltage already we know that. So the rectified voltage, we can say that it is rectified voltage is, I will draw all three voltage here. We need not worry about primary. Already we know secondary voltage alone because rectifier is getting input voltage only from the secondary. Primary is as input. So I'm not going to. This is my Vs. I told you the transformer is 0.25. So Vs, this is 50 volts positive side. Vp positive. Correct? This is called as minus Vp, which is nothing but minus 50 volts. This is called one cycle. Okay. Now, this is passed as input to the diode. So, what will be diode output? Diode output will be like this. Okay. This is called a positive cycle. These three are called as, because it is going to repeat itself, this is called as positive half cycle. Okay. The bottom one is called as negative half cycle. These are called as negative half cycle. Please note that this voltage, when given to diode, the output will be only positive half cycles alone. Please see that during negative half cycle, diode output. This is output. Correct? We say the V diode output. Okay. That is going to only positive cycle. So you can see the negative cycle is not appearing. This process of allowing only the positive cycle so that the current flows from the transformer secondary to the diode to the load resistor impulse. This voltage called as rectified DC voltage. Note down. Rectified DC voltage. Right? Already told many classes. AC means the voltage will have positive half cycle and you will have equal amount of negative half, same shape, same amplitude. Correct? Positive 50, negative 50. Positive is half sinusoidal, negative was half cycle. So this is the first cycle. This is second cycle. Second, positive half cycle, negative cycle. Exactly same. Repeat. This is called as periodic waveform. If the period of positive negative cycles are same shape, it is increasing discrete with respect to zero. It is called as periodic signal. Correct? It is going to repeat one cycle, again positive, negative. Second cycle, positive, negative. Third cycle. Like that, within one, we say 50 hertz, 50 times the cycle will repeat. That's why it is called as periodic wave. Okay, cyclic wave, these are different name used. Okay, if I pass my sinusoidal AC voltage into your this one diode, it will produce an output which is as a rectified DC voltage. In fact, it is called as half wave rectified. Why? The diode conducts only in one direction. When anode is positive, when cathode is done, then current will flow. That also above 0.7 volts. For understanding purpose, say that if cycle is positive, output will pass and current will flow through. Okay, in that case, current will flow through this circuit. Let me remove unwanted things. Okay. Please take the notes. This is my diode. Correct. This is plus. This is minus. That is anode. Anode. This is cathode. This is the diode. Diode anode is connected to transformer one secondary coil. Other coil is connected to, this is called load resistance. So the current from the transformer secondary coil flows inside diode, comes out, and again it comes back. So it circulates. This is the DC current. This is called as DC current flowing in the circuit. Okay. How the current will be. So this is rectified DC voltage. This is 0 volts. This is nothing but positive V peak. Please see that negative effect 0 volts. So that means this portion is blocked. Who is blocking? Diode is blocking. That process is called as rectification. Correct? The diode allows current flow in one direction only, from anode to cathode. That happens during the positive half cycle of the sine wave. Correct? Negative half cycle, anode is negative, cathode is positive, the diode is reverse bias. Already we know that. So current cannot go in the reverse direction, not allowed. Only one direction. This is the ID. Current is flowing anode to cathode during the positive. So this circuit is called as half wave rectifier. Okay. Now that we know what is the half wave rectifier, then we have a circuit called a full wave rectifier. Next we will discuss. But only thing is, I will draw this waveform here for understanding purpose. In which case, you will see that waveform will be like this. This is positive half cycle, this portion, and this is positive half cycle, and this is third positive half cycle, correct? And this is negative half cycle, first cycle, negative, and again, this is negative, correct? So that is possible if you go to full wave rectifier. How the full wave rectifier look, I will tell that. Okay. Full wave rectifier also will have a transformer which is supplied with VP, primary voltage. VP is called, substitute this one. For example, 220 volts. And my coil is already what we talked. I think coil were 200 turns. This is 200 turns. N1 equal 200 turns. This is core. This is N2. N2 is the secondary coil. Okay. But one thing is in this is the secondary coil is what you call a center tap. Correct? It will have 3 wires coming out to secondary coil. Correct? So this will be connected to diode, one diode. It uses 2 diodes. So when I said D1, this is D2. Please see that D1 anode, this is cathode, anode, cathode. Anode is connected to one end of the secondary coil, N2, this end. I say 1, 2, 3. Then second diode D2, its anode also connected to one end of the secondary coil, other end of the secondary coil. Then this is called as center. For example, there is this middle one is called center tap. 2 is called as center tap wire, which divides the number of turns in equal size. That means from middle position you are taken. So now here only your DC voltage is coming. How the DC will come? DC will come like this. So this is called a full wave rectifier. You got it? Full wave rectifier. Okay. So now, if I apply the AC voltage to my full wave rectifier here, my input voltage is like this. That is Vs. This is Vs. This is Vp. Vp is 220 volts and 50 hertz. And my transformer ratio is 0.25. TR equal to this one. So this voltage will be positive side. This will be we said 25 volts. This will be negative 225 volts. So it will vary. This is Vs. after step down, and this is applied to the rectifier, which is called as full wave rectifier. We already mentioned. The full wave rectifier, the output will be like this. You can see that this is positive half cycle, and this is positive. This is positive, that is brought down. And negative in half rectifier not appearing. Now you can see that this is negative half cycle. Negative. Okay. This is called as full wave rectifier output voltage. Note down, full wave rectified output voltage. Okay. Output voltage is waveform is like this. So this is 0 volts. This is 0 volts. You can see that it goes to positive VP. No negative. So this is called as full wave rectifier signal. Okay. Now that we understood two types of this one, half wave rectifier, full wave rectifier, please take the diagram. So in exam, sometimes if you ask to draw the half wave full wave rectifier and do some calculation, what will this one, you can find out. So for the next thing is, if I am supplying some input voltage to half wave rectifier, let us take the half wave rectifier itself. VP. Take the circuit. This I call D1 diode. Only one diode will be there. This is connected to load resistor RL. Now, this is my VS. TR equal to, I said 0.25. And I am giving 220 volts and 50 hertz power supply. Here it will be VS will be 50 volts and the frequency will be same, 50 hertz. F will be this one. Now, what will be the DC voltage will be coming out? We know that when we wanted to write the voltage, correct? I said this is 25 volt AC, correct? This is nothing but 25 volt AC. That means it is varying sinusoidally 50 times per second. The maximum is plus 25 volts and minus 25 volts. And it is varying from 0 to like sinusoidally. This is the VS. Okay. This is an AC voltage. Please note that this is AC voltage coming from secondary of the transformer. So the VS can be written as V peak into sine omega t. This is the correct representation AC voltage, where VP is called as the peak AC voltage. It's called as, what is the AC? This is called peak positive voltage. Same amount is there, negative side. So this is called as minus VP. This is called as plus VP. Peak voltage or secondary voltage. Okay, not primary. Peak here, I can say the PK. So you won't get confused. Correct? VP is primary voltage. PK means peak voltage of any AC voltage. It's the secondary voltage. Now, the voltage, this voltage is represented in a mathematical formula like this. Vs equal to Vpk of the secondary voltage multiplied by sine omega t, where omega is called as angular velocity. Is called as angular velocity of the waveform, AC waveform. What is omega? Omega can be written as 2 pi f, where f equal to the frequency of the supply, which is nothing but in this case 50 hertz. In India, it is 50 hertz. 50 into 2 into pi into this one is called this omega. What is the angular frequency? Radians per second. Within how many radian it rotates, rotational moment, because sinusoidally is varying. Within 1 second is called as omega, which is called as angular velocity in terms of radians per second. And we know that if I wanted to express into frequency f equal to omega divided by 2 pi. correct? Then if I know the omega, I can find the supply frequency F also using this formula. The one thing. Now that I given to half rectifier. Now, what is the output? Output is a rectified VDC. We call this DC voltage, which is nothing but being half a rectifier. What part will come? Only positive cycle. This will come, and next this will come, then next this will come. Okay, so these are the positive half cycles coming from the diode at this point. This voltage is nothing but this rectified half a rectified voltage. Now, because of voltage there's a current flow. We call this IL, which is nothing but ID. That means this current is coming from a transformer flowing through diode, flows to the circuit close. Okay, we can say that secondary current IS equal to ID equal to RL. Correct, for the circuit. All are equal. Okay, how will you calculate this DC voltage? That's what our question next step. We know the supply input voltage, which is nothing but VS. VS is, we can know that supply voltage always mentioned by this one. This is my input to rectifier. Right? What is my output? Output is pulsating DC. This is pulsating. This is called as pulsating DC. Right? It's not constant DC. So output voltage is, we call the VDC equal to V peak divided by pi. Okay. And this can be written as 1 by pi integral 0 to pi Vp into sine omega t dt. 1 by pi is a constant coming outside this one. If we integrate this term with respect to 0 to 2 pi and apply the upper and lower limit, you will get VDC. What will VDC? If I do this, integrate this one, it will be going to be VDC equal to Vp divided by pi. Okay. We can say PK, VPK division. What is VPK? VPK equal to VRMS multiplied by √2. Already we know that. Okay. So from this, we can find it. If we know the VRMS, for example, what is our VRMS now? We gave 220 volts in primary. It was stepped down by 0.2 times. So this is my VP, primary voltage. VS was 220,000. We can say round number easily 200. So this is going to be 50 volts. Correct? 200 into 0.25 is going to 50 volts. VS. So the VS is called a VRMS voltage. This is nothing but VRMS or secondary voltage. What is my VPK? VPK of this VRMS is nothing but 50 into √2. 50 into 1.414. Okay, you got it? So you can calculate. Once you know the VP, then you can substitute that value here and divide by pi is nothing but 3.14. That will be the VDC. VDC are the half wave rectifier. Then what will be the current flowing through this one? IDC load, because current is flowing through this. Because my diode is conducting, we know that diode voltage, anode and cathode is above 0.7 volt. Voltage of anode is 0.7 greater. Diode will start conducting, current will flow. Current will flow like this. Current circuit will go. This is called IDC. How will you calculate IDC? IDC equal to IPK divided by pi. Correct? Again, the current also will, how the current will vary in this? Current also will be varying. Half of cycles only. Pulsating current. This is the I peak. Okay. This is I peak. Current also varying because voltage varying sinusoidally. Okay. Now, please note down the formula. You can expect problem in the exam. Correct? A transformer, 220 volt transformer, 200 volt transformer 200 volts supplied to primary, and it is a transformer ratio equal to 5, and this is applied to transformer with 200 volts. Then what will be secondary voltage? It will be transformer ratio times the input, that is 0.2 multiplied by 100 is going to be 20 volts. Okay, that is my V secondary voltage. Okay, that multiplied by root 2 times is going to be peak voltage of that circuit. Once we know that, then we can calculate this. IDC equal to this one. Now, IDC equal to I peak divided by pi, where I peak equal to VPK divided, take down this formula, you can expect problem, into RS plus RD plus RL. Okay, so what is RS? Where RS equal to resistance of the secondary coil, transformer secondary coil. Okay, RD is called diode resistance. Okay, third one is RL is load resistance. What is load you are connecting? Load resistance value. Okay, already I told you in the many times, the RD is called dynamic resistance of transformer. Dynamic resistance of diode. Extremely sorry, diode. Okay, the RD value theoretically will be equal to infinity when diode is not conducting. When diode is not conducting, during the time, RD will be infinite ohms. Okay, when diode is conducting, due to voltage applied, diode is conducting when the input or VD input or greater than 0.7, RD will be equal to 0 or maybe 0.1 ohms to 10 ohms, depending upon transformer current rating. Okay, so that means you can almost negligible. RD can be neglected, provided the third one is called load resistor. What is load resistor? We are connecting a motor or a circuit. His resistance is called a load RL. So then this coil has resistance, secondary coil RS. This has a resistance which is called dynamic RD. So you can see that these three resistors to be added up, and if you divide by the VS, that is the current IS, correct? So we are talking about I peak. You can note in this formula. Okay. Once this is known, then we can write IDC equal to V peak divided by pi. This can be written as V peak divided by pi divided by RS plus RD plus RL. Correct? This is going to be IDC. Note on this formula. Okay. Once RS value, RD value, RL is given, and if he has given V peak value or VRMS, from VRMS you can calculate V peak. Correct? Then from that, divide by resistance value, you can calculate IDC. Okay. DC current can be computed. Okay. So we can write VDC equal to VP divided by pi minus IDC into RS plus RD. Okay, this is another formula you can write. Once RS value, secondary coil resistance and dynamic resistance, we know that very low, if it is known, and then you can calculate VDC using this formula. Okay.
Sir, I think like the VDC in the top, I think it should be IDC. IDC, right, sir?
Yeah, this is IDC. Yeah. Which one you are talking?
The IDC equal to VPK, VPK by pi is there, right? Will it be, means I peak, sir?
No. So the IDC equal to Vp divided by pi divided by resistance. Here I forgot to mention. Because current equal to voltage divided by resistance. No,
Okay. Okay. Sure, sir. Sure.
I made a mistake. Sorry. Thanks for this one. Okay. So this is one term. Now we know how to calculate VDC and also IDC using this formula. Okay. Then next thing is you have what you call a rectifier factor, a ripple factor. Ripple factor. Ripple factor is generally represented gamma. Ripple factor represents gamma. Gamma equal to ripple voltage divided by DC voltage, VDC. VDC voltage. Okay. This can be written as RMS value of AC components. Just note down, next class I will explain. Divided by DC value of waveform. What waveform? Half wave rectified waveform. Okay, you can note down this. So we can say that gamma equal to, in terms of the current also you can take IRMS of ripple current divided by V, correct? Divided by IDC. This also you can do. So ripple factor is one of the important parameter. If value smaller is better. Ripple factor should be smaller. Generally it will vary 0 to 1. If it is, it can vary, it can be multiplied by 100. There sometimes the ripple factor will be vary from gamma. Ripple factor is 0 to 1 or 0 to percentage. 100% vary. This multiplied by 100 will be percentage. I will stop here because already time up. We'll see tomorrow by 6 o'clock. Okay. Thank you. Please give your attendance before leaving.
Sir.
Yeah.
Hello. Sir, just a normal question to you, sir.
Yes,
how
please.
how the exam will be there, sir? It's a straight question or how it will be, sir?
Last time we wrote no exam, no?
Yeah, this time
problem, sir, or
problem.
No, the problem will be there.
Okay.
So they explain the working of, for example, synchronous motor with vector diagram, waveforms, or induction motor working with waveforms. I explained how the rotating magnetic creates. You have to show the diagrams, circuit, and also problems will be there.
How many problems, sir?
No, small problem. No, 30. I said we will have 30 marks. No.
Okay,
sir, may I ask a question, sir?
Yes, please.
Syllabus will be till BLDC motor, right?
Yes,
sir?
up to BLDC motor.
Okay, understood. Sir, one question in general, probably just a doubt. Okay. For induction motor, when we were revising, we had a doubt. So induction motor, we are going to use the same transformer principle to step down the voltage while sending it to the...
There's no separate transformer, correct? You have
Yes,
this stator coil, that is primary, you are applying, it produces a rotating magnetic field. That magnetic field go and hits the rotor, correct? If it is a wound rotor, coil will be there. If it is a squirrel cage, magnetic copper conductor bars are there, no? That will cut the magnetic, they pick the voltage, they call induced voltage.
Understood.
That's how it works as a transformer. Just like a primary supply, secondary voltage indicate rotor voltage induced. Once voltage induced, already coil is short circuit, current flows. When current flows, it produces magnetic flux. That is called rotor magnetic flux. That magnetic flux will get locked with the rotating magnetic field and rotate along it, so the rotor rotates.
Understood.
Since it is an induced motor, we call it induction motor.
Okay. Thank you, sir.
Okay.
Sorry.
Please give your attendance before leaving. Yes, please.
Sir, for exam, you are sharing the link to us, no, sir?
I will send a link.
Right.
So when will we receive email from code office for the exam, sir? Because last time we received like a week before.
For which exam?
No, Amit.
Amit,
Professor will
This is not from
Oh.
code office online exam. It is from professor side.
Oh,
You
okay,
want-
okay.
If
Thank
you
you,
want
thank
from code office, I can give the work to them, they will conduct.
No,
sir, it is
No,
better.
sir, I got confused, sir. Thank you, thank you. Thank you,
Okay,
Arunachalam,
Last
sir.
time we had a very bad experience, sir, please.
okay, no, I will conduct myself. Okay, don't worry.
Yes, sir.
Thank you, sir.
Last time
Thank you,
very, very
Arunachalam.
bad.
So only one thing is you have to switch on your cameras. You should not say my camera is not working.
No, sir, we will.
That is institute rule. Online exam is
Yeah.
camera should work. You should have the
Sir, we
bandwidth
will-
is not there.
Sir, we will open the camera, and if you have any doubts, sir, we will ask the answer from you also, sir. Please.
You can ask me. You can ask me. I will give good, nice answers. Correct?
Sir. Great, yeah.
I want people like Rahusan. Correct? Will be very happy. I can give nice answers, so you will get 500 out of 500 out of 100.
Sir,
Very kind of you,
sir, I know one thing about you is that you are a student loving teacher. So
Yes, I am
definitely,
sure.
yes,
Yeah.
sir.
I want my
Definitely.
student to get my 100 to 100 as grade.
So I'm
Yes,
sure,
sir.
sir, you will help us in doing the exam also.
Definitely.
Not a problem. Yes, sir.
Definitely. Questions will be like that so that all of you can get sent up.
Right,
Yes,
sir.
sir.
Provided you prepare. Provided you
Sir,
prepare.
sir,
Please see that.
Already started, sir.
Already
I
started.
know
We are
that you will
doing
do
second
that.
revision, sir, now.
Very good. Very good. We'll see. Okay.
Thank you, sir.
Thank you, sir.
Okay. Thank you. See
Sir.
you tomorrow. Yeah. Yes, please. Please give your address before leaving.
Yes, sir. Sir, Aditya.
Thank you, sir.
Okay.
Thank you.